Hello everybody and welcome to another video, and in today's video we are going to be using the R Studio to model the concept of the Poisson distribution. We are going to be using just two codes, the D Poisson and the P Poisson. So basically the D Poisson help us to calculate individual probabilities attached to the success in a Poisson distribution, and the P Poisson actually help us to calculate the cumulative probabilities of the success in a Poisson distribution. Now the example I'll be using is the fact that within 2 minutes 5 cars was actually passing through a school gate. I used the same example for the Microsoft Excel video and the SPSS video relating to the Poisson distribution. That is the last two videos, so you can actually check that out maybe before you actually watch this video. So in that case, our lambda, that is the fixed rate at which the event is occurring, is actually equals to 5. So let's play around something. So let's say 5 cars are actually passing through the school gate in 2 minutes. So what is the chance that 8 cars will pass through the school gate within the same 2 minutes? So to do that, we are going to be using the D Poisson. So we just come right here, D Poisson. All right, so we click on this. So our x is actually equals to 10. Our lambda is actually equals to 5. That is the fixed rate at which the event is occurring, and our log should be false. And now we'll click on enter. So this is the chance that 10 cars will be passing through the school gate in 2 minutes, given that 5 cars will be passing through the school gate in 2 minutes. So we can also do what is the chance that 5 cars will pass through the school gate in 2 minutes. So that's going to be the same code. Just copy this and we paste it here, and then we actually just change this to 5. Okay, and then we click on enter, and it gives us the chance that 5 cars will be passing through the school gate in 2 minutes. So what if I want to get all of the probabilistic value for the success from 0 down to 20, and I want to visualize that is, so what is the chance that 0 cars will pass through the school gate, 1 car will pass through the school gate, 2 cars will pass through the school gate, down to 20 cars. All of these are done with the fact that in 2 minutes 5 cars will be passing through the school gate. All I have to do is to say D Poisson. Okay, that's x is equals to, so we have 0, then I use the semicolon to go from 0 to 20, so that's from 0 down to 20. My lambda is actually equals to 5, and the log is actually equals to false. And once I run this code, it's going to give me all of the values from 0 down to 20. Okay, now I can actually visualize this value. All I have to do is to attach a variable to this code. I can say Poisson, attach a variable to it, then just create a variable for this. Okay, Ctrl C, then I paste it right there. All right, and it has created this variable for me, so I can just say scatter plot or the scatter smooth of the Poisson. All right, and this is the scatter plot that actually defines the distribution, and as you can see, we have those right here. It goes down like this. Okay, and that is that about that. So what if we're interested in the cumulative Poisson distribution? So what if I want to ask questions like, so what is the chance that at most 8 cars would be passing through the school gate, given that in 2 minutes 5 cars have actually passed through the school gate? So I'll be using P Poisson. All right, so that is this. Okay, so our Q is equals to 8, our lambda is actually equals to 5. So we have the lower tail is actually equals to true, and then we have our log to be equals to false, and we're good to go. We click on enter. Oh, okay, I think I'm supposed to say this as true. Please let me rerun the code again. All right, so this is supposed to be uppercase. All right, so So this is the chance that at most 8 cars will be passing through the school gate in 2 minutes. So what if I want to get all of the cumulative probabilities from 0 down to 20 and then I want to visualize it? All I have to do is to write this code. I can just copy this and then I actually paste this here. So I just move this from 0 semicolon down to, is this colon or semicolon? I can't really tell. Down to 20, and yeah, that's it. I click on enter, it runs the code, and these are the values. So these are the cumulative values from 0 down to 20, and if I want to visualize this, I can draw a scatter plot for this or a bar chart for this, anyone I want to use. So let me use a bar chart this time. But before I use the bar chart, let me actually tag this to a variable. So I can say cumulative Poisson. All right, so I tag that to this. All right, so I've created the cumulative Poisson variable. So I can say the bar plot. Okay, so of cumulative. Okay, Poisson, and click on enter, and this is the bar plot or the bar graph that defines the cumulative Poisson distribution of the same experiments of 5 cars passing through the school gate in 2 minutes. And this is how you can use RStudio to actually model the concept of the Poisson distribution. If you learned something new from this video and you also enjoyed this video, please don't hesitate to give this video a like and also subscribe to this YouTube channel. Thanks for making it to the end of this video, and we'll see you in the next one. Bye for now.